Okay, so we now understand how to do one bit addition at a time, but one bit addition is not of any use to us. We of course need to be able to add more than one bit at a time, and that's where we're going to introduce this concept of a ripple carry adder. So ripple carry just simply means that we're going to take the carry out of a less significant bit, and we're going to carry it in to the next most significant bit. If you think about it, let me scroll back up here to one of the examples that we did. When we did this addition right here, that's just what we were doing. When I did this calculation of 1 plus 1 yields 0 with a carry out of 1, realize that we're sort of carrying the 1 from this least significant bit into the second bit. And then the carry out of that went into the third bit. And the carry out of that went into the fourth bit. And the carry out of that went into the fifth bit. So what we're really finding is that we can build a circuit that emulates the flow of data that we saw when we actually did the calculation. So the carry out of this bit goes to this bit, the carry out of that bit goes to there, and the carry out of that one goes to there, and then there's a carry out of that bit, which would be available for external use, or you could even wrap it down here and see that's the fifth bit of the sum. So we can think of these 1-bit full adders as being a simple slice of the addition, and that when you then take the carry out of each bit and send it into the next bit, that's where you're gluing the slices together to get a whole multi-bit adder. So here you can see this is what the overall circuit would look like for, say, an 8-bit adder. This is going to take two 8-bit numbers. We have here A0 to 7 and B0 to 7. And then the carry n for the overall circuit, which is almost always going to be 0. We're almost always going to take that carry in to be 0. And then the sum is going to be 8 bits of sum. And then the carry out, you can think of that as sort of S8. Because if you had two 8-bit numbers and you added them together, you can get a 9-bit result. So it's usually good to think of this carry out as being the 9th bit of the sum. Now, adders like this are known as ripple carry adders. And the reason for that is because the carry has to ripple from the least significant bit to the second, from the second to the third, from the third to the fourth, and from the fourth to the output. This means, for example, that this A3 plus B3 calculation can't complete until A2 plus B2 has been completed, which can't complete until A1 plus B1, which can't complete until A0 plus B0. These do not actually work in parallel. The calculations do not occur all at once. You have to complete one, then the next, then the next, then the next. And that's not optimal. That's actually kind of a problem. It turns out that ripple carry is not actually a very good circuit. Because if you have a 4-bit adder, of course, that's not such a big deal. But often we're going to be dealing with 32-bit adders or 64-bit adders or 256-bit adders. And in those cases, the amount of time it takes for the calculation to occur will be 16 or 32 or 64 or 256 times, as long as it takes to do a single full adder calculation. And as you're going to see in the example that you're about to do, that can be the difference between a computer that's operating at a reasonable speed and a computer is operating at a definitely not reasonable speed. It turns out that if you're a professional engineer, a professional designer of a computer system or any sort of a digital system, you would never use a ripple carry. I mean, it would be like instead of doing multiplication, I'm just going to add that number repeatedly. You would never actually do that. But in reality, you would use a different type of an adder, which you'll study next year in digital logic design, called a look-ahead adder. Well, a look-ahead adder is definitely better. It will definitely give the correct results more quickly, but it's more complicated. And this is your first time encountering binary arithmetic, so we're going to go ahead and stick with the ripple carry adder for now. But I just want you to know that the ripple carry adder is not the ultimate solution. There are many better solutions, and in fact, some that are even better than the look-ahead adders. So for right now, we're going to live with it. We know that it's going to give the correct result, but I want you to be aware of the fact that it gives the correct result slowly.